Hi, everybody. Welcome to another virtual Sky Tonight event with the amazing Dr. Lisa Will, the Fleet's resident astronomer. My name is Andrea Decker. I'm the Adult Programs Manager, and I'm super happy to welcome you all to another online event. And Lisa, since I'm doing this the second time, I'm just gonna give it right over to you.
All right, so thank you very much for inviting me back into your homes to do this presentation. Can you hear me now okay? Perfect. All right, so let me go ahead and share the screen then. As Andrea said, I'm Dr. Lisa Will, Professor of Physics and Astronomy at San Diego City College and the resident astronomer at the Fleet Science Center. And the first Wednesday night of every month, we do the Sky Tonight show where we talk about what's up in the night sky tonight, and then we usually specialize to a different topic every month. And this month it's going to be the moons of the solar system, which are way more interesting than the planets, by the way. I just have to get that in there. So what we have on the screen in front of you is the dome of the sky above you. At the bottom of the screen is south. At the top of the screen is north then. East is to your left. West is to your right, and then basically the point directly overhead would be right in the center of the screen that you're looking at now. So we're going to get you started on a tour of the night sky, starting with this line. And so what is this line? I guess I should let you know first that I have the sky set for tonight at around 9:30 this evening. So if you go outside, this is kind of what it should look like. And what that line is up there is the path of the sun called the ecliptic. And so you can see that the months of the year are up on the sky. And what the ecliptic is, what those months are on the sky, it shows you where the sun is on any given day of the year. So since I have this set for 9:30 tonight and it's June 3rd, June is below the western horizon because the sun would have already set. And so if you want to go outside and take a look for where the ecliptic is tonight, go take a look for the moon, because you might notice the moon is down there by where the abbreviation for November is. And that's because not only is the ecliptic the path of the sun, the moon and the planets also hang out over there too. And that's because our solar system is shaped like a pancake and the planets revolve around the sun all relatively on the same plane. And so the ecliptic is really kind of the plane of the solar system up in the sky. And in fact, the constellation that the moon is in tonight is the constellation Libra. And you might recognize Libra as being one of the signs of the zodiac. And in fact, the signs of the zodiac gained cultural importance because they are the constellations along the ecliptic. They are the constellations that the sun moves through. So these are the constellations that show changes over time as the sun and the moon and the planets pass through them. So let's take a journey along the ecliptic, going from west to east across the sky. First starting with, let's get this here, Gemini. And so the constellation Gemini, is named because those two bright stars that you can see there at the top are Castor and Pollux, who were twins from Roman mythology. And they do look very similar to each other up in the sky. That's why they were called twins. Now, what's interesting about that is that you might think then that they are at similar distances from our solar system, but they're not. One of those stars is about twice as far away as the other ones. To give you an idea of how far they are away, the star that's towards the top of your screen is the star Castor, and it's about 52 light years away. And the one of these, let me see, yeah, so that's Castor and this is Pollux. Pollux is about 34 light years away. A light year is the distance that light travels in a year. So when we take a look at these stars up in the sky, we're not seeing them as they are, we're seeing them as they were years ago. So like I said, Pollux is about 34 light years away. So when we see it in the sky, we're seeing it as it was 34 years ago. And these two stars, the idea of calling them twins actually predates Roman mythology. This area of the sky was referred to as the Great Twins in Babylonian astronomy as well. So let's continue our journey along the ecliptic, going from west to east across the sky. And now we have the constellation Cancer, which represents a crab. You might notice you're not seeing a whole lot of bright stars in that region. And of all the zodiac signs, Cancer is actually the faintest. It's the most difficult to see up in the sky, especially from a metropolitan area like San Diego. Now you might be wondering, what crab is this supposed to be? And the hero Hercules on his adventures fought the Hydra, which we will also come across tonight. And while he was fighting the Hydra, a crab bit him on the foot. And this is that crab, because the goddess Hera didn't like Hercules. And she's like, you know what? I'm going to make this crab immortal. I'm going to put this crab up in the sky. Just to irritate Hercules, basically. So this one's a really hard one to see out in the sky, the night sky, just with the eye. But the constellation of the zodiac, just to the east of it, just to the east of it, is actually easy to see even from a metropolitan area like San Diego, and that's Leo the Lion. The most prominent parts of Leo the Lion are actually the backwards looking question mark at the front, which is the head and the torso of the lion. And there's that triangle on the back that's representing the tail of the lion. And both of those geometric features you can pick out. I've been able to see them easily from here in San Diego. The brightest star in Leo is the one right at the front here. It's called Regulus, or Prince, or Little King, because we often think of lions as being kingly. Regulus just looks like one star up in the sky to the naked eye, but if you look at it through a really, really good telescope, it's actually a system of 4 stars making up that brightness in our sky, located about 75 light years from our solar system. And then the second brightest star is Denebola at the tail of the lion. And they're very similar in brightness up in the sky, but Denebola is only about 36 light years from our solar system. Once again, just reminding us that we don't have good depth perception on the sky because not all stars are the same brightness. So there can be bright stars in the sky that are actually really far away, or faint stars that you can see in the sky that are much closer. So no good depth perception on the sky. The next constellation of the zodiac to the east along the ecliptic is Virgo, the Maiden. It's the second largest constellation of the 88 constellations that modern constellations that astronomers use. The brightest star in Virgo is named Spica, which comes from a term that means ear of wheat. And when the mythological portrayal often shows the maiden holding an ear of wheat, we see this constellation prominently in the spring. And so it's actually usually associated with fertility and rebirth and renewal. And so that's where the mythology comes from in that. And one of the things about Spica that you might find interesting, it is the 15th brightest star that we can see in the nighttime sky, located about 260 light years away. And so once again, that means we're not seeing it as it is, but as it was about 260 years ago. The next sign of the zodiac to the east is Libra. That's over where the moon is tonight. And Libra stands for scales or balance, often thought of as being the scales of justice. It is the only zodiac sign that doesn't represent a living creature, mythological or not. And it's one, again, another one of those faint constellations. You would have a hard time saying, where is Libra on the sky tonight? So you can find it tonight because the moon's in it. And the moon itself is in about full phase this evening. So go take a look for the moon if the clouds in your area cooperate. The brightest star in the constellation Libra is named Zubenel-Ganubi, and it's located about 80 light years from our solar system. And Zubenel-Ganubi is a term that refers to a claw, but the scales of justice don't have a claw, but the constellation next to Libra does. And let's take a look at that. We have Scorpius rising in the southeast around 9:30 tonight. And it is probably my favorite sign of the zodiac to look at in the sky, simply because it actually kind of looks like a scorpion. You've got the torso, and then later in the summer, as the summer goes on, you'll be able to see more of it. In the early evening, you'll see it has a little stinger at the end. But what I wanted to point out in Scorpius is that there's this bright red star there that's named Antares. And it is an example of a red supergiant. This is a star towards the end of its life, burning through its nuclear fuel. And it's huge in terms of its radius. It's over 800 times the radius of the sun. So what does that mean in practical terms? Well, if I were to put Antares in our solar system where the sun is, Mercury, Venus, Earth, and Mars would be inside of it. That's how big it is. It's located about 550 light years from our solar system. And then you might be wondering, who does the Scorpion represent? Well, the Scorpion actually is associated with the constellation Orion, who represents a hunter. They are actually directly opposite each other on the sky. So as Scorpius is rising, that's when Orion starts to set. And every summer, that means that Orion flees when the Scorpion starts to come after him. So we have these constellations on opposite parts of the sky, yet their mythology still connects them together. And then I want to name one more sign of the zodiac before we start to venture to other parts of the sky. And that sign of the zodiac is Ophiuchus, the serpent bearer. And you might be saying, well, you know, you normally don't think of Ophiuchus as being a sign of the zodiac, but it is, because part of Ophiuchus, or I guess I should say the ecliptic, passes through part of Ophiuchus at about the beginning of December. And so there are 13 constellations that the sun travels through. And so those are the signs of the zodiac along the ecliptic that are visible in the sky tonight around 9:30. Let's look away from the ecliptic. There's a really huge constellation up there right now, and that's Hydra, the sea serpent or sea monster. And what I love about this constellation is that it's huge because it's connecting the dots between a whole lot of faint stars. Let me go back one. Now take a look at the part of the sky where you just saw Hydra. You notice how there aren't really many bright stars there. In fact, there's only kind of one of them, this bright star right there. That is the star Alphard, the brightest star in Hydra. And its name comes from an Arabic phrase that means the solitary one, because it is all alone over there. And it is an example of an orange star that is towards the end of its life, located about 177 light years from our solar system. So that's the only constellation south of the ecliptic I'm going to mention tonight, because at 9:30 tonight, from our point of view in San Diego, Hydra takes up almost all of the sky underneath the constellation, or underneath the ecliptic. So now let's take a look at some of the constellations north of the ecliptic, starting with Hercules, who we mentioned earlier in association with Cancer, the crab. Hercules is the 5th largest constellation up in the sky, and if you wanted to go look for Hercules, you'd be looking for this sort of parallelogram, I guess I should say, up there on the sky. Its brightest star is named Kornephoros, which comes from a Greek term for club bearer, because Hercules is usually depicted as holding a club over his head. And that brightest star is located about 140 light years away. And I'm mentioning these numbers just to give you a sense of scale, how different in distance some of these stars are from us, even if they might look very similar to each other up in the sky. In tonight's sky at 9:30, if you went outside and I asked you to pick out something that you recognized, you would probably look a little bit to the north and point out these stars here, which you know is the Big Dipper. But the Big Dipper is part of a larger constellation called Ursa Major, or the Big Bear. Just the rest of it isn't as easily visible to us. What you call the Big Dipper is something called an asterism, which means a grouping of stars that's not actually in and of itself a constellation. And so this is one of the largest constellations on the sky. And lots of cultures in the Northern Hemisphere who can see this refer to this part of the sky as being a bear, which I've always found that kind of interesting. And then we can follow the arc of the handle, and we say we arc to Arcturus. We arc to Arcturus, which is the brightest star in the constellation Boötes, the herdsman. A lot of people, this is a constellation that you can see from a metropolitan area, And a lot of people say it looks like a kite, but it's a constellation that's easy to see in the sky in spring and in summer. So in my mind, it's an ice cream cone, right? Because I'm totally about the ice cream right now. So at the base of the ice cream cone, that is Arcturus, which its name comes from a term that means the guardian of the bear due to its proximity to Ursa Major up in the sky. And Arcturus is one of the brighter stars that you've seen in the spring and summertime sky. So going into summertime sky right now, located about 40 light years away. Oh, and that was it. That was rather abrupt. All right. So that's basically the tour of the nighttime sky, some of the brighter constellations you can go at and look at tonight around 9:30 in this orientation. But what we had decided to talk about tonight was moons of the solar system. And
Lisa,
yes?
sorry about that. Before we move to the moons, just because there's two questions related to the night sky, I thought maybe you could take those real quick.
All
so
right.
One question is, how do you measure light years?
So how do we measure distance to get light years, or what is a light year in terms of meters? Those are two different things. I will tell you that distance is the hardest thing to measure in astronomy. I can give you a sense of scale. In terms of our solar system, when we talk about light units, our moon is about 1.3 light seconds away. So it takes light from the moon about 1.3 seconds to get to us. Our sun is about 8.3 light minutes away. So light from the sun takes 8.3 minutes to get to us. Our solar system is a few light hours across. The distance to the closest star system is a little bit over 4 light years away. So how do we get those measurements? By a variety of methods. The easiest one to use for stars that are nearby is something called parallax, which is something that you have noticed in your everyday life. If you were to take a look at your finger with one eye and then your finger with the other eye, you would notice that the finger appeared to move even though you didn't move it. And that has to do with the distance between your eyes and then the distance to your finger. And so if I can judge how much a star moves at two different locations on the Earth's orbit, right? Same telescope pointed at the same star, but see how much it moves due to the change in our position. I can just use geometry to figure out how far it is away. So parallax is what we use to get to the closest distances to the closest about a million or so stars. And a million stars might sound like a lot, but that's nothing. So hopefully that answers your question.
Thank you. And then the other question was, are all stars part of a constellation?
Oh, that's a good one. So are all stars part of a constellation? The answer is yes. When we show you these images up on the sky, we often show you the stick figures or the mythological representations. But the International Astronomical Union has broken up the sky into 88 constellations. So when you take a look at a constellation up in the sky, also imagine sort of a box around it. We do have constellation boundaries defined such that every star is a part of a constellation. That answer your question, hopefully?
Thank you so much. So now I think we'll go to the moon.
All right.
Moons.
Let's go to the moon. Let's start with our moon first because it's so pretty. This is our moon as you're used to seeing it up in the nighttime sky. It is a significantly large moon. It's one of the largest moons in the solar system. I think it's the 6th or the 7th largest moon in our solar system. And in terms of the size of the moon to the planet it orbits, it's definitely the largest moon once we no longer consider Pluto a planet, and don't start with me on Pluto. In terms of the size of the moon, to give you a sense of scale, it's about 1/80th the mass of the Earth. It's about 1/4 the radius of the Earth. And so you'd probably have the idea that the moon is smaller than us, but it's probably not as small as you think it is compared to the size of the Earth. The moon orbits us once per month, we'll just say, and that's actually how the month is defined. And if you wanted to measure the distance between the moon and the Earth, like we said, it's about 1.3 light seconds away. You can also fit about 30 Earths in between us and the moon, which makes it sound maybe far away, but it's not. It's our closest neighbor by far. And what we were looking at in the previous slide was the near side of the side of the moon that always faces the Earth. Here are images of that near side again on the left and the far side on the right. The far side of the moon is not the dark side of the moon because as you can see, it's not always dark, right? So we have the near side of the moon and the far side of the moon. The title on this is Clementine Global Albedo Images 750 nanometer filter. What does that mean? It was taken by the same spacecraft with the same camera using the same wavelength of light and also at the same level of sunlight illumination. So we are directly comparing what the near side of the moon and the far side of the moon look like to each other. And you will notice that they look very different. The near side has a lot more of those dark splotches on it that we call the lunar maria. On the far side, not nearly as many. And astronomers think that the lunar maria are due to impacts that were so big that they dredged up lava from underneath. So basically the impact poked through the crust of the moon and brought lava up from the mantle of the moon. And so we think that the reason why the far side doesn't have as many maria is the same reason why the moon actually always keeps the same face to us as it orbits us. This is something called tidal locking. You know that the moon helps to cause the tides here on the Earth, but the Earth's gravity should be trying to cause tides on the moon. So a long time ago, early on in the Earth-Moon system history, the moon got what we call tidally locked. It keeps one side always facing the Earth, just like the Earth's oceans are always trying to point along the line towards the moon. And what we think this also did is that the core of the moon is shifted towards the near side, towards the Earth, and so that the crust of the moon, basically the thickness of the top layer of the moon is thinner on the near side than the far side. So impacts had an easier time on the near side dredging up volcanic material to the surface. One of the questions that we always have to ask ourselves when we take a look at images from the moon, and this is an image from Apollo 14, that's astronaut Ed Mitchell laying out a line to some of the scientific instruments that they deposited on the surface of the moon. And you can see the footprints there. And you might notice that there's no blue sky. And that's because the moon doesn't really have an atmosphere. Its gravity is so low, only 1/6 the gravity of the Earth, that it would have a really hard time holding on to gases in an atmosphere around it. So we call that something, it's correlated to something called the escape velocity. The higher the escape velocity of a world, the easier time it has keeping gases around it. Now, the fact that the moon doesn't have an atmosphere has some interesting implications for the moon. That means that there's very slow erosion on the moon. The only thing that causes erosion on the moon really is impacts. Whereas here on Earth, a synonym we use for erosion here on Earth is weathering. And so you know that erosion on Earth can be due to rain and wind and running water. We just don't have that on the moon. So really slow erosion, which means that impacts on the moon that happened hundreds of thousands of years ago can still be visible today. Without an atmosphere, there's no protection from those impacts, and there's no protection from radiation. The Earth's atmosphere blocks out gamma rays, X-rays, and most of the ultraviolet radiation. All the stuff that you normally think of as damaging to human cells, well, you don't have that on the moon. And you don't have the greenhouse effect either. There's no greenhouse gases in an atmosphere to moderate temperature. So the temperature on when it's nighttime or in the shade, all of the heat, so the sunlight's heating up the rock that you see in this image, all that heat can be released up into space. And so the nighttime temperature, or the temperature in the shade on the moon, is about -280 degrees Fahrenheit. But if you were to stick a thermometer in the dirt, so to speak, if you were to take the temperature of that ground right now where it's in the sunlight, it can be about 260 degrees Fahrenheit because all the radiation is getting in and helps heat up the material more. So when I talk about it to my students, one of the things that atmospheres can do is moderate temperature like it does here on the Earth, and we don't see that on the moon. And so going back to the point about no erosion, you might notice that the astronaut there for Apollo 14 is walking back and forth from the lunar lander to where he was setting up a scientific set of instruments, and you see his footprints. Well, the Lunar Reconnaissance Orbiter, NASA's Lunar Reconnaissance Orbiter, actually has taken images of all of the Apollo landing sites. And so you can see the landing, basically the land part of the landing module for Apollo 11 over on the left. And then the one on the right is showing the Apollo 14 landing site over where you were seeing Edgar Mitchell walking across the moon. And what I want to note to you is if you see those dark streaks going in between the descent stage and the Antares descent stage going over to ALSEP, which was the name of the scientific instrument package, you're not seeing individual footprints, but you're seeing a footpath there. And Apollo 14 was a long time ago. Apollo 14 would have been 1970, 1971. And so it is almost 50 years ago. And when these images were taken, it was 40 years ago, and you could still see the footpaths. But you and I know if we went and took a hike in Balboa Park, that footpath wouldn't last more than a few weeks or maybe a few months before it got covered up again due to erosion. So no, or very slow erosion on the moon because it doesn't have an atmosphere. One of the things we are interested in about the moon is whether or not it has any water. And so this is data from India's Chandrayaan moon mineralogy mapper. And that blue stuff there is where you're seeing minerals that on Earth we find in the presence of water. And so the blue represents there a water absorption strength when taking a look at parts of the moon in the infrared. Now, although that does give us evidence that perhaps there is water on the moon locked up in perhaps ice form, it would still be drier than the driest desert on Earth. So if we want to go to the moon, we are going to have to take our own water with us. And that's our moon. This is the beautiful image called Earthrise taken by the astronauts on Apollo 8 back in 1968. And I like showing this because it does give you the contrast between the moon and the Earth. The moon doesn't have an atmosphere and it looks gray and barren. The Earth, it has an atmosphere which has allowed it to keep liquid water stable on the surface. And our Earth is the only planet in the solar system that has liquid water stable on the surface. And it's the only world that looks like that up in the sky. So what other moons are there in the solar system? I can't tell you about them all. I wish I could, but let's take a little journey. So Mars has two moons, Phobos and Deimos, fear and dread, because Mars was the god of war, so he would bring fear and dread with him. I said Mars has two moons, but I put four things up here. Two of them are asteroids, and I do that for a reason. The two moons that the arrow is pointing to are Phobos and Deimos. The other two are asteroids out in the asteroid belt, Gaspra and Ida, and when you take a look at them, you can see that all these objects look similar to each other. In fact, Mars' two moons, because of their chemical composition being different from Mars, and their small size, and their irregular shape, they are likely to be captured asteroids. Now, how small are they? This is Deimos, whose longest dimension is only 9 miles. Now, I can walk 9 miles, which means this cannot be a big distance at all. And so when we take a look at it, Mars doesn't have moons the way you think of our moon up in the sky as being this big shining orb. These are basically little city-sized rocks orbiting around Mars. And this is Phobos. Its longest dimension is about 17 miles. And when we take a look at them, you might notice that they have craters on them, no obvious evidence of an atmosphere. Some of the streaks here, it could be due to a large impact. In fact, that I believe is Stickney crater over there on the right, that big dip on the right that you're seeing. So those are Mars' two moons. And you might be like, wow, Mars has two moons, we only have one. Jupiter has 79. And so I want to show you some of the moons of Jupiter. Most of Jupiter's moons are small and irregularly shaped. There are also, sorry about the noise, they are also probably captured objects, captured asteroids, captured cometary bodies maybe. But the four largest moons of Jupiter are called the Galilean satellites because they were discovered by Galileo back in 1610. And these are moons that you would feel very comfortable calling moons. Their names are Io, Europa, Ganymede, and Callisto. And to give you a sense of scale, Our moon is about the same size as Io and Europa over there on your left. And when I show you all of these together, you can immediately say, wow, they don't look anything like each other. Their colors are very different from each other. So let's take a look at a few of them separately. This is Io. And Io is kind of a reddish orange, and that comes from sulfur compounds that are getting outgassed from active volcanoes on Io. That is actually the thing that makes Io interesting. It is the most volcanically active object in the solar system. In fact, that's one of the reasons why when you take a look at Io, the places in between the craters seem smooth. And that's because those are mostly volcanic craters and the volcanoes are actually resurfacing Io. Now, we wouldn't have expected a moon as small as our own moon to be volcanically active, but we think this is due to the tidal forces of Jupiter acting upon it and not letting the ground rest. So Io is tidally locked to Jupiter, but gravitational influence of Jupiter and one of its other nearby moons is causing tidal friction to heat up the interior of the moon and cause volcanic activity. So, and Io, every time we've sent a spacecraft close enough to Io to detect volcanoes, we have seen them. These are images of volcanic plumes you can see coming off of Io that was taken by the New Horizons spacecraft in 2007. And this is what Io looks like, not in visible light, but in the infrared from NASA's Juno spacecraft, which is currently in orbit around Jupiter. And it's not meant to take pretty pictures of the moons. It's meant to take pictures of Jupiter itself. So this is just a bonus. And you can see all these volcanic hotspots all over, all going on all over Io. So it's the most volcanically active world in the solar system, which makes Io very interesting. This is Europa. And what you're taking a look at here is a world covered in water ice. And there are cracks in that ice, as you can see, sort of making this pretty sort of fragmented pattern, broken shell pattern almost, all over the surface. And when we take a look at them close up, what you're noticing here is you're not seeing a lot of clear impact craters. What you're seeing there are sort of weak spots in the ice where it's collapsing. And then you're seeing reddish material that's upwelling from underneath. And this is a world that doesn't have an atmosphere. And so if we're getting, not getting impact craters on it, there must be something resurfacing it, basically smoothing out over those impact craters. And so what we think is going on here is that we're getting fresh ice. And so to have fresh water ice, you have to have a source of water. And so this is one of the reasons why we think Europa actually has a liquid water ocean underneath its surface. In fact, if we could measure the amount of water that we think exists underneath the surface of Europa is probably more water than we have here on Earth. This is Callisto. Now, what makes Callisto interesting here is that it's covered with all these dots, and these actually are impact craters. But the reason why these impact craters are highly reflective, they look white to you, is because Jupiter and its moons are about 5 times further away from the sun than we are. So it's cold out there in the solar system. So the stuff that we look at, like Callisto, that looks like a big ball of rock to us, actually has a lot of ice content in it. And that's why the craters are bright. This world is geologically inactive. You can see it has a lot of impact craters on its surface. If it had something going on like liquid water close to its surface or volcanism, it wouldn't be as heavily cratered. And then this is Ganymede. Ganymede is the largest moon of Jupiter, and you can really see the whites, the white of the ices in this case. And one of the things that I think is particularly interesting about Ganymede is, let's show it to you in perspective with Jupiter, the planet it orbits. Jupiter is the largest planet in the solar system. Ganymede is the largest moon in the solar system. Ganymede is larger than Pluto. Ganymede is larger than the planet Mercury. But by definition, it can't be a planet because it orbits a planet. But if I were to take Ganymede and throw it in orbit around the sun, you'd be like, oh yeah, that's a planet due to its size and its shape. The next planet out from the sun is Saturn. Let's talk about some of its moons. We mostly think of Saturn with its rings, and I have the rings of Saturn here shown with a couple of its moons for contrast. Saturn has 82 moons. Only one of them is large. Most of them are fairly small, and a lot of them are likely captured objects as well. I wanted to show you a few of these moons in particular. This is Phoebe. Once again, heavily cratered, so an old surface, small moon. This is likely a captured asteroid because of its shape and its cratering, and it looks like those other asteroids that I showed you. But let's contrast that with a really interesting world. This is Iapetus, and this is so. These moons are also tidally locked to their planets. They are orbiting around their planet. So this Iapetus is orbiting around Saturn with one face always facing Saturn. So one of its hemispheres is always pointed in its leading direction around the orbit, and one of its hemispheres is always pointed in the trailing direction. And what you're seeing here is the color contrast between those two hemispheres, that obviously we're picking up material on the side that it's leading into that you're not necessarily getting on the trailing side. One of the, and there's also, this image doesn't quite capture it, but along its equator, there is a ridge that goes around about 3/4 of that moon. It's a really interesting, bizarre object. All right, Mimas looks like the Death Star. I have to show it. But the reason really why to talk about Mimas is that when you take a look at that crater that makes it look like the Death Star from Star Wars, that crater's huge. In fact, if it had been much larger, we probably wouldn't be talking about Mimas because it probably would have destroyed Mimas. There is a diameter of crater versus diameter of what it hit ratio that above a certain ratio, the object's going to be destroyed. Don't ask me what that ratio is because it also depends on what the objects are made out of, right? But you can imagine that there is a size ratio there that's going to make a difference. So I always have to show Mimas because it looks like the Death Star and I'm a nerd. This is probably my vote for the most fascinating moon of Saturn, although there's another one I'm going to mention that is a good contender. This is Enceladus, and isn't it a lovely, lovely surface? We're once again seeing a surface that is mostly water ice, and there are cracks in the surface, but you'll notice one side has more impact craters than the other. And so I want to show you this a little bit more in detail. Here's a smooth part. If you take a look at more at the bottom of this image, it's smooth with respect to impact craters. You're not really seeing them, but if you take a look up at the top right, you'll notice more impact craters. So obviously, part of this world is getting repaved more often than the rest of the moon is. So what's doing the repaving? Well, NASA's Cassini spacecraft took images of Enceladus that showed these geysers, and these are liquid water geysers. So you know how I said that our Earth is the only world in the solar system where we know liquid water is stable on the surface, but there are other worlds where we're seeing geyser activity, getting water from underneath the surface to above the surface. And that's what's going on with Enceladus. We have really good evidence for that. For Europa of Jupiter, there is some evidence of geyser activity, but it's not as strong as we have for Enceladus. So what we think going on here is we do have basically a rocky core with perhaps a global ocean or a larger reservoir, though, towards the southern part of the region, so that it's easier to get geyser activity, and then a thicker ice crust or perhaps a thinner global ocean towards the north. And so that's what we think is going on with Enceladus, right? Aren't the moons way more interesting than the planets? Just saying. And then this is Titan with the moon Saturn's, one of Saturn's other moons, Tethys, there for contrast. And you'll notice that Titan looks fuzzy. That's an atmosphere. That's a thick atmosphere. It's so thick we're not seeing down to the surface here in visible light. Titan is the second largest moon in our solar system, larger than Pluto, pretty much the same, about the same size as the planet Mercury. And its atmosphere is mostly nitrogen and argon with traces of things like methane and propane and ethane, these hydrocarbons up in its thick atmosphere. In fact, its atmosphere is so thick that the atmospheric pressure at its surface is higher atmospheric pressure than you would have here on Earth. So you have a higher atmospheric pressure than the Earth. You've got these hydrocarbons in the atmosphere, and Saturn is about 10 times further away from the sun than we are, so it's really cold out there. So these hydrocarbons in the atmosphere can actually rain down from the sky. And we see evidence in radar images of lakes on Saturn's moon, Titan. And we see structures like this in several parts of Titan. And what you're seeing here in the inset area is showing how it looks like the level of the lake of the hydrocarbon has changed with time. So lakes of hydrocarbons out on Titan. So that's why a lot of people think Titan's the most interesting moon in the solar system, or especially for Saturn, but I am really intrigued by Enceladus personally. Let's continue our journey throughout the solar system. 2 more planets to talk about. We have the moons of Uranus. Uranus has 27 moons. They're all named after Shakespearean characters. And I don't have as many pretty images of them to show you because we have only sent spacecraft to Uranus and Neptune once. It was Voyager 2, and it flew by Uranus and Neptune really, really quickly and took images where it could. Although Titania and Oberon and Umbriel and Ariel there look fairly round, they might remind you of our own moon. They aren't as large as our moon. They are smaller. So Uranus does not have any large moons. Now, Uranus orbits the sun on its side, and its rings go around its equator, and its moons go around its equator too. So I wanted to give you that sort of tilted perspective there to see what it looks like. And then my personal favorite moon of Uranus is Miranda because it looks all messed up. We don't really know what went on here. Is this an object that got shattered? Did something graze it? Maybe someday we'll send another spacecraft out there and get more up-close data on Miranda. And then the 8th and final planet in the solar system, Neptune. Neptune has 14 moons that we've discovered so far. And only one large moon, and that's Triton. So what you see here in this image is Triton and then some of the other smaller moons. And you'll notice none of those have good images because we just frankly don't have any to show you. But Triton itself is really kind of interesting. You'll notice those kind of dark streaks down at the bottom. That is also geyser activity. So this is a geologically active world, except the geysers are liquid nitrogen geysers, so a little bit different than you might expect. Triton is also likely a captured object. It is in a retrograde orbit around Neptune, which means it's orbiting Neptune opposite the direction that Neptune is rotating. The object in the solar system most similar to Triton is Pluto. And I'll mention Pluto in a moment because those are the moons of the planets, but other objects can have moons. So the large object on the left is the asteroid Ida out in the asteroid belt. And the Galileo spacecraft took this image as it was flying from the Earth out to Jupiter, and it had to fly through the asteroid belt to do it. But you'll notice that teeny tiny little rock off to the right, that's Dactyl, and Dactyl orbits Ida. And so, yeah, asteroids can have moons. This isn't the only case that we know of. And then yes, Pluto, I'll talk about Pluto. Pluto does have moons. It has 5 moons. The 2 objects that you see here, the one on the top left, that's Pluto's largest moon, Charon, and then the object on the bottom right, that is actually Pluto itself. You'll notice how different in color they are, except for those reddish compounds, and how big Charon is compared to Pluto. Charon is half the size of Pluto, and they actually orbit each other in a dance. And so one of the questions about Pluto is that if you're going to call it a planet, what do you call Charon? Is it a double planet? And then Pluto's other 4 moons are very, very small. And you'll notice the Styx, Kerberos, and Hydra in particular look kind of glommed together. It is actually possible that those small moons are due to mergers of even smaller moons together. So Pluto actually has 5 moons. So to end our discussion of the moons and to start taking some of your questions, I just wanted to show this wonderful graphic that shows you some of the selected moons of the solar system to scale. You'll see the real variety and environments of moons in the solar system. They actually have a greater variety of environments than the planets do. So if you actually want to study something really interesting in the solar system that is different with every object you look at, I'm a fan of the moons. I could talk about them for about 5 more hours, but I won't. So let's go ahead then and take some of your questions.
Wonderful. Thanks, Lisa. Good segue. So we have 15 questions.
Okay.
I'm gonna challenge you to be as brief as possible. I want to get to as many as we can.
And would you like me to stop sharing the screen or leave it?
If that's up to you, actually. I don't know if it's going to be helpful to go back to some of the slides, maybe.
All right, so I'll leave that up then. All right, let's go for the questions.
Cool. So the first question was, does the moon have a moon?
Our moon does not have a moon unless you want to count the artificial satellites that we put in orbit around it. So there's artificial moons, but not a natural moon.
Thank you. Then are any of the stars that we see actually galaxies?
Oh, that's a great question. With your naked eye, you can see one galaxy here in the northern hemisphere, and that's the Andromeda Galaxy, but you'd have to be out somewhere really dark to see it on a good night, and it would be a fuzzy blob to you. However, so you're not really seeing individual galaxies then likely and mistake them for a star. However, if you're looking through a telescope, sometimes you'll see fuzzy blobs in the telescope, and those can be galaxies.
Thank you. So here's a question. I think it came up when you talked about our moon. And it says, so the soil samples taken from the impact craters are different than the soil samples taken from the crust?
So that's an interesting one, particularly for our own moon, where the Apollo landing sites were first on the Maria because they're smoother, and then close to where what we call the lunar highlands are, so they could pick up rocks from different locations. And so the coloration tells you that they're different materials. Those dark regions that you see up on the moon actually have a higher iron content, and the lighter regions have a higher aluminum content. So the mineral composition is different.
Got it. Thank you. And what determines which planets or moons have gravity?
Great question. So gravity is determined by mass. So anything that has mass has gravity, which means I have gravity, but I don't pull objects towards me because the Earth has a lot more gravity than I do. So it's going to more mass than I do. So things are going to be attracted to the Earth instead. But anything that has mass has gravity.
Thank you. And then next question is, do asteroids contain water?
They can. They can. Especially when we take a look at data from the Dawn spacecraft of the asteroid series, the largest asteroid in the asteroid belt, there's bright splotches on it that kind of have the chemical composition of a briny or a salty water coming from underneath the surface. And you can get water coming from underneath the surface in ice form in the version of something called cryovolcanoes or ice volcanoes. Yep, okay. So they can have it.
Cool, I think I knew that from watching a TV show. See, TV can totally educate you once in a while. And I think you touched on this question just a little while ago. Why the moons of Jupiter have different colors than Mars moons or Earth moons? And is that, again, because of the minerals?
It's the minerals, and in the case, as we get further and further out in the solar system, there's a lot of ice, so moons tend to get brighter or more reflective on their surface. But when you see things like Io, that orange color comes from sulfur compounds from its volcanoes. When you see Titan, that's its atmosphere. It's the chemical compounds in its atmosphere. So it's all about chemical compositions. And then Callisto, and that part of Ganymede that is dark, part of that is deposition of meteorite impacts, and some of it is due to something called radiation darkening, which is esoteric. But so it can be actually due to fragments of rocks too. So no, it's just, they're fascinating because I love it because you can just look at this slide and say, oh, they're not all the same. Like I cannot have one sample moon that's going to explain all of them. That makes it fun.
So do you know what exact mineral makes Callisto so colorful?
No, off the top of my head, no. I mean, the most common materials are just going to be your basic silicates like you have here on Earth in terms of the common compounds. But the materials on the surface can be different. And also for worlds that don't have atmospheres, you get interaction with the radiation from the sun doing some coloration changes, which is part of why Titan and Charon and Pluto have those sort of reddish colors to them. They're compounds called tholins that we don't really see here, just naturally occurring out in your garden, but because of conditions in the outer solar system that you can get them.
Thank you so much. And then I know this next question is difficult for you. Why isn't Pluto a planet?
The International Astronomical Union came up with the definition of a planet much more recently than you might expect in 2006 that said to be a planet, it has to orbit a star, which Pluto does. It has to have gravity sufficient enough to force it into a spherical shape, which Pluto does. And then it has to have swept clean its orbit, which Pluto has not because it crosses the orbit of Neptune. Another way to think of it is it has to be the largest object. It has to basically win its orbit, because if Pluto were to run into Neptune, Neptune would win and we'd be like, Pluto never existed, and Neptune would just not care. They will never run into each other, unfortunately, due to what we call a 2/3 orbital resonance, so they will never be in the same place at the same time. But in reality, one of the reasons why Pluto was demoted, I guess is what a lot of people say, is that it is not like the 4 rocky planets or the 4 gaseous planets in our solar system. If we wanted to call it a planet, we would have to call it a 3rd category of a planet, and there's hundreds of objects just like it out there. So Pluto, in fact, is one of the largest objects out in the Kuiper Belt. And I know it's designated as a dwarf planet, but that's a horrible term and we're not going to talk about it. It's horrible.
But Pluto would not be immune to another planet then, just because it's been demoted from.
No, because it still orbits a star. Still orbits a star.
Perfect. That probably leads into the next question: is what determines the name of the moon?
So, so some of these names are older than others, depending on when they were discovered, because some of these moons were discovered, like I said, the Galilean satellites were discovered back in 1610 by Galileo. The names of the moons now are determined by certain naming conventions. So like I said, for Uranus, they're all Shakespearean characters. For Neptune, because Neptune was a sea god, all of the moons of Neptune also are references to sea gods and sea creatures, gods and goddesses. And so we do come up with a naming convention as we go throughout the solar system. And you can actually look that up at the International Astronomical Union, because there's actually reasons, like every crater, every volcano, everything out there gets named following certain rules.
Of course, there's rules for everything.
Rules, I know.
So do proto-moons and submoons orbit the larger moons of the planets? And the question was asked because of Dactyl and its asteroid.
So we always think in terms of gravity, the smaller objects orbit the bigger objects in terms of their mass. And then just like our moon is orbiting the Earth, Dactyl is orbiting Ida as Ida orbits the sun. So we kind of drag it along with it. So that's its own separate case. I don't know of any moons of planets that have moons.
Thank you for that. And then can or could all those moons orbit the Earth?
It would look amazing in the sky if they did, but they can't. The Earth, in terms of its gravity, would have a hard time holding all of these in stable orbits.
Sounds logical. Hold on, I'm trying to read all the questions. Will Triton get ripped apart by Neptune?
Yes. So Triton is in what we call a retrograde orbit. So like I said, it's going opposite the direction that Neptune rotates. It's unstable, and so it's spiraling in towards Neptune. And before it could crash into Neptune, the tidal forces of Neptune will pull Triton apart, likely turning it into a new set of rings. So that if we were to come back to our solar system, maybe 500, 600 million years, in the future, I wouldn't talk about the rings of Saturn. I would be talking about the rings of Neptune. What's next? Andrea, I think you're muted.
Oh, that's right. Sorry about that. I tried to get my keyboard clicking not into the sound. So are any of the moons possibly livable with the right gear?
Oh, with the right gear, that's interesting. Some of them, the gravity is so low, we wouldn't be comfortable. Some of them, you know, the more atmosphere, the better. I think if water is important to human life, right? We would need to look for places that have liquid water. And the moons of the solar system actually are easier in that way than the planets of the solar system are. So that's one way to answer that question. You might want to actually, in terms of humanity's exploration, we might want to do that. But yeah, they'd still be hard to live on.
Yeah. Okay, is Eris a dwarf planet?
Eris is a dwarf planet. In fact, it is the object that was discovered that is about the same size, if not larger, than Pluto, which sparked the Pluto discussion. Or actually, I shouldn't say it sparked it. The Pluto discussion had been going on for a couple decades. It made us have to finish the Pluto discussion of whether or not it's a planet.
And then what would happen if we lost our moon?
That's a really interesting question. We think that having a large moon has stabilized the tilt of the Earth's axis. So we could flop around a bit more over long periods of time. If we didn't have a moon, it would have dramatic environmental impacts in places like tidal estuaries and stuff like that, which I am not qualified to answer about, but your biology friends could certainly answer questions about that. So it would definitely have, I think some people think, doesn't the moon block us from getting hit by impacts and stuff like that? And the answer is no, it really doesn't help us that way. But in terms of stabilizing the tilt on our axis, so keeping the seasons stable here on Earth, and anything that's in a tidal zone would be changed without the moon.
Thank you. And then there's Peter. Hey, Peter.
Hey, Peter.
Peter said he read that the Earth may have had 2 moons in the far past. Could you describe what that may have been and what happened to create just the one that we have now?
Well, you know, we had a second moon just recently. We get temporary moons sometimes that get caught by the Earth's gravity and sort of whip back out. Our moon itself was made via collision of material, and so if we had a second moon, it is quite possible it could have been part of that glomming together that made our one moon. But it's really hard to tell going back in time whether or not we have lost a second moon that way, because the gravitational, it would have to have been lots of its possible impacts on our geology would be hard to see, because we do have tectonic movement and stuff, tectonic plate movement and stuff like that could have hidden some of that. But that's an interesting question. There are some answers about the moon that we just can't know. But the most favored hypothesis for how the moon was formed is that a large impactor, probably about the size of Mars, hit the moon, or hit the Earth, I should say, kicked up material from the Earth's crust and its mantle, and then that stuff went into orbit and over time coagulated and formed the moon. Because if you take a look at what our moon is made out of, it's very similar to the Earth's mantle and crust.
Interesting. I did not know that. And then I think there's 2 questions we can kind of combine. So one is, which moon is the biggest? And the other question is, how many of the biggest moon in the galaxy would it take to fill the sun?
Oh goodness, that's an interesting question. So Ganymede is the largest moon in our solar system. And like that's a little bit bigger than the planet Mercury. To give you a sense of scale, let's see. You saw how small Ganymede was though compared to Jupiter, right? And so our sun is about, let's see, well, I guess we could think of it as being about 10 Jupiters across. And so volume was proportional to the volume or the radius cubed. So think of like off the top of my head, say like 1,000 Jupiters. Well, then that's a lot of Ganymedes. And so the answer is a lot. A lot.
Truly a lot, yes.
I always remember roughly off the top of your head. One thing to remember is that the sun, you could fit about 100 Earths across the diameter of the sun.
Crazy.
That's a scale there.
So big.
It's big.
A question about our moon. Why is our moon so reflective? Does the moon have a lot of ice? Is that because it's so reflective?
That's a great question. And it's not actually icy because at our distance from the sun, the temperature is still high enough that you're not going to get a lot of ices on the surface itself. But the brighter rocks have a higher aluminum content. And so, like the aluminum foil you might have in your kitchen, how it's shiny. Minerals that contain a lot of aluminum tend to be lighter in color.
Thank you. And I like the next question. Why is our moon called the moon? It does not have a pretty name like Ganymede or Europa.
Yes, it does. It's moon. It's Luna. It's Selena, depending on what language. I think it makes more sense if you ask yourself, why do we call those other things moons to begin with? It's because they were like our moon. They orbited a planet. And then to make them different than our moon, we had to give them names. Does that make sense?
Yeah.
I know it sounds like we don't have a pretty name, but ours was first. Everything else got named after us.
Perfect. And then I know we're a little bit over time, but I'll try to take one or two more questions. I think this is an interesting one. Can we say that planets are the moons of the sun?
So we tend not to talk about them that way, but if you were just talking about scaling models up, right? Moons orbit planets, planets orbit stars, stars can orbit the center of galaxies, galaxies can orbit the center of a galaxy cluster or the gravitational center of a galaxy cluster. So if you wanted to make that analogy, yes, but I would never call a planet a moon of a star. A planet's still a planet.
Thank you. And then do you know how often planets gain or lose the moon?
That is really hard to know. I've been a community college professor for 20 years. And you'll notice I said that I think, Jupiter has 79 moons now, but the first time I taught that class, it had 16. And it's not that it gained a bunch more moons. What happened was our technology got better and we sent more spacecraft out there. So we've been discovering more moons, which is why so many of the moons we discover are small, because we're just able to see more and more small ones. So did they gain them recently? Did they gain them a long time ago? That's really hard to know because we've only been able to see them now.
Interesting. Okay, so I think we'll get to just one more question, and I'm sorry, there's so many, and I love that everybody's so engaged and has so many questions. It's so exciting. Which moon is NASA studying most, and for what reason is it interesting?
All right, so if you ask astronomers, we want to study all of them, but there is a particular mission coming up called Dragonfly. It was just awarded last summer, and some of the instruments on it are going to be built by Malin Space Science Systems from here in San Diego County. And it's going to go to Titan, that moon with the atmosphere that orbits Saturn. And we're really interested in that because its atmosphere is very similar to what we think Earth's early atmosphere might have been like. And so the interesting thing about that world, liquid hydrocarbons on the surface, an interesting atmosphere, organic compounds. And so this mission is going to be a lander that's a quadcopter. So it's going to be like a lander that lands. It's going to do some science, and then it's going to fly somewhere else and do more science. And so it's going to be able to rove like a rover, but it's going to do it by flying through that atmosphere. So that mission just got funded last summer, and so expect it towards the end of this decade.
Wow.
It takes a while, sorry.
No, I can understand why. I mean, there's a lot of science and engineering and funding that needs to go into that. So I can understand why it's just not an easy thing to do in a year or two.
Yes, we wish.
Lisa, I'm going to stop sharing your screen if you don't mind.
Not a problem. There you go.
Thank you so much. Perfect. I want to thank everybody for joining us tonight. Lisa, thank you so much for a fantastic job for educating us on the night on the sky that we can see when we go outside after this presentation. And I hope everybody will go outside and take a look and see if they can find what Lisa presented on today. And thanks for the presentation on the moons and all the rest. Lisa will be back next month on the 1st of July. As many of you might know or not, July is Comic-Con month in San Diego. That means there's the big comic convention that will not be happening this year, at least not live. They'll do some virtual events, but we will still be back with Lisa's special Sky Tonight show because she likes to go a little nerdy in July for Comic-Con.
Even nerdier.
Even nerdier, yes. So in July, we're going to look at Mars and the facts and the myths. So are there little green men on Mars? Do they fly around in saucers? What other myths can you think of right now?
Yeah, no, which we're going to talk about Mars depiction in popular culture. It should be fun. Maybe I'll cosplay for that one. We'll see.
Perfect. I would like that very much.
Bring out the Jedi robes.
And then I'm going to ask my wonderful colleague Carla to put something in the chat box. If you enjoyed tonight's event, we appreciate your support. Please consider donating to the fleet. And I think Carla has the link more quickly available than I do right now, so I'm asking her, but I'm putting her on the spot, so sorry, Carlita. And we have more science events coming up, so if astronomy is not your only science love, there's going to be more science event that the fleet is excited to put on. The next event is going to be on June 22nd, and we're going to be talking to the La Jolla Institute for Immunology on their work on antibodies for the COVID crisis. So if that's something you would be interested in, please go to the Fleet Science Center website, and that's fleetscience.org. And you can find all the relevant information to our upcoming virtual science events, as well as the Sky Tonight astronomy talks there. You can also use the website to sign up for our newsletter. We would love to stay in touch with you. And with that, I think I shared everything I wanted to share. Lisa, is there anything else you want to some parting wisdom?
No, I'm just grateful to see how many people are interested in showing up to these events. I know that we miss being under the planetarium dome with you, so we're very happy that we can still help bring the sky to you in whichever form we can. And I look forward to talking about Mars and popular culture with all of you next month.
Thank you so much, Lisa. I can't wait either. And with that, thank you very much, everybody. Have a wonderful night, and we'll hope to see you again soon.
Bye-bye.
Bye.